Okay, so we would like to compute this limit, which is pretty much identical to what we did on a previous video for a sequence. The solution is exactly the same, so it doesn't really matter that it was a sequence. So let's do it once more. So what we will do is we will multiply and divide by the conjugate quantity in order to get rid of the square root, at least as far as the difference is concerned. We're not going to get rid of the square root completely, but at least for the difference. Because what we initially have, if we look at the initial limit, we will realize that it's what we usually refer to as an indeterminacy, meaning the square root tends to infinity. This tends to infinity. We have the difference of these two things, and without further analysis, we cannot really say what the limit is. Okay, so the top will become square root of x squared plus x squared minus x squared over square root of x squared plus x, and this will be the limit as x tends to infinity of x squared plus x minus x squared over square root of x squared plus x, which is x over square root of x squared plus x. And now we just need to simplify this as much as possible. So we will do something similar to what we do for polynomials. So we will think of the top as x times 1. We will think of the bottom as a polynomial. We want to factor out the strongest quantity. And in this case, we will have an x squared inside the root, which we will try to factor out. So this will become the limit as x tends to positive infinity of x times 1 over x times 1 plus 1 over x plus x. And what we can do now is just factor out an x from the denominator, which is really straightforward because both components have an x in front. So this will be x times 1 over. You don't need to write this silly x times 1. I'm just writing it so as to emphasize, because I've seen this mistake many times, that when you eventually do the cancellation, which is right here, there is an 1 that is left on the top. So that's a pretty silly thing to do, but that's the reason that I'm writing this, just as a means of emphasis. Okay, so now the only thing that has a variable in it is this 1 over x that tends to 0, so we can plug in right away, and this will be square root of 1 plus 1. Square root of 1 is 1. The whole thing is 1/2, and that completes the computation of this limit. Thanks for watching.